we're going to talk about the knowledge from the derivatives, the higher order derivatives, and we're going to work together to solve the problem given.
For the domain, we know that we don't have any restriction, so our domain will be x belongs to all real. For finding the x-intercept and the y-intercept, first we have to substitute y with 0, and then we got that x equals 0. And for y-intercept, we substitute x with 0, and we got that y equals 0. So the coordinate will be 0, we have to substitute x with minus x, and we got that we don't have any symmetry because not all the signs are changed and not all the signs are equal. We already know the domain is equal to all real numbers, so we don't have any vertical asymptote. To find the horizontal asymptote, we have to calculate the limit as h approaches 0. And we substitute everything with infinity, and we got the form infinity minus infinity. And then we calculate the limit as h approaches 0, and we got infinity. So we don't have any horizontal asymptote.
Okay, to take the first derivative x, we need to get the first derivative and we got it right here. Then we need to equal the first derivative to 0 to get our critical points. Since we can clear x in a simple step, we only get one critical point that is equal to 1. 1 it will be the critical point, and we are going to get the answer equal. Okay, so now we can afford that 1 is our critical point. To see if it is right, we are going to substitute some values on x in the first function that we have. We substitute first minus 1, and the graph is going down, so it will give us a negative behavior on the graph. Then we substitute to 0. Since 0 is smaller than 1, it will be also down. But when we reach 2, or also it can be 1, we know that the graph will be going upwards since it passed the value of 1. The graph is represented like this, so we can see that when it touches point 1, the graph will go upwards, so it will be a minimum point because it changed here, and since then go upwards. So to get the intervals, then we do the same graph, but only we know that since 1 to 4, it will give us negative results. So we put minus infinity to 0 and to 1, that is a critical point, to infinity. Then we substitute values from 0 to negative infinity will always give us minus negative form of the graph, so it will go downwards. From 0 to 1, since the graph doesn't touch yet 1, it will give us again negative values, and the graph will go down. Then from 1 to infinity, the graph changes and goes upwards, so we can know that the values will give us positive and the chart will go upwards.
Well, we are going to explain now the second derivative and the concavity test. With this, we will demonstrate that the second derivative will be f of x equals to 12x to the 2. With this, the concavity test will help us to understand that f of x equals to 0, 2x to the 2 equals 0, the root of 0 will be 0, and the answer of x will be 0. For instance, y will be 0, of course, so the influence point will be 0, 0. With this, we demonstrate with minus infinity to 0 equals a number like minus 1 will be 12, and 0, to infinity, a number like 1 will be also 12, so it will be a line.
We have to graph our function, and we can see that it's the graph right here. For the range, we can see that it goes from minus 3 to infinity.
Well, in the graph now, we can see that This is our main function. Their second derivative and the second derivative of the derivative.